morning, dear students. Welcome back. I am your physics professor, Dr. Nagaraj. So today I am going to start with numerical problems on quantum mechanics. That is module 2 for applied physics for computer science stream. Already I have uploaded numerical problems, solved numerical problems on quantum computation. So I have made 2 videos and I am getting very good response from your side. And very shortly I am going to upload even other videos also. Please keep watching and definitely you will be benefited by these videos. They will help you for your forthcoming examinations. Well, dear students, let us proceed with the first numerical problem. The problem goes like this. Calculate the de Broglie wavelength associated with an electron with kinetic energies of 1500 electron volt and 2000 electron volt. So here we have to find out kinetic energy associated with the electron. So you should know the mass of the electron. But you need not have to remember mass of the electron. It will be given in the question paper. A ಮೇಲ್ಗಡೆನೆ constant values ಅನ್ನೆಲ್ಲ mention ಮಾಡಿದ್ದಾರೆ. In the instruction part itself you can see the values of Planck's constant, permittivity or permeability and speed of light, Boltzmann constant, mass of the electron, charge on the electron, all these things are already will be there, so you need not have to remember the values. Just you start with the equation. See, in this problem kinetic energy is given, so you have to know the equation which connects the wavelength with kinetic energy. That is one thing. Second thing, whenever energy is in electron volt, remember you have to convert that into joule, because electron volt is not the SI unit, joule is the SI unit. Only while expressing the answer, final answer of energy, we put in electron volt. Otherwise, while doing calculations, we have to convert into joule. And you know how to convert that into joule. Whenever you have electron volt, just multiply by 1.6 into 10 power minus 19. That way, 1500 is 1500 into 1.6 into 10 power minus 19. Like that it goes. Okay, now with this much introduction, let us start with this numerical. The problem goes like this. Lambda, first I take this into 2 parts. First part, lambda, that is equal to h by square root of 2me. Dear students, while doing numericals, no, better you keep your calculator by the side of you, and calculators are allowed even in the main examination also. Scientific calculator is allowed. Okay, well, that is equal to first part, h is 6.625. so this is what I told, this will be there in the question paper, so you need not have to remember this value, divided by square root of 2 into mass of the electron is 9.1 into 10 power minus 31, energy is 1500 into 1.6 into 10 power minus 19. Okay, that is all. That's all about the substitution. You can pause the video and check the calculation. 2 into 9.1 to the power of minus 31 into 1500 into 1.6 to the power of minus 19. For that I have to take the square root, and then I take it to the numerator, and then I multiply it by 6.625 to the power of minus 34. When I do, I get the answer as 3.149 or 16 or 145 into 10 to the power of minus 11 meter. So you need not have to write all the decimals. You can approximate it to third decimal or second decimal also will do. So this is about first numerical problem, and here you need not have to put it in 10 power minus 11. You can put it even in angstrom also. Okay, anyway, final answer is this one. Now with the same method, you try the second one, that is lambda is equal to h by square root of 2me only. This time it is 6.625 into 10 power minus 34 divided by square root of 2 into 9.1 into 10 power minus 31 into 2000 into 1.6 into 10 power minus 19. Okay, dear students, please do this calculation. Meanwhile, I will also do along with you. Okay, take your calculator and simplify. So I hope you are doing. Better you do along with me only, then simultaneously you will be practicing the numericals. Okay, so this is a right method in fact. Okay, so I take the reciprocal of this and then multiply by 6.625 to the power of minus 34. I got the answer as 2.745 into 10 to the power of minus 11 meter. So this is the answer for the second energy. I hope you got this problem. This is not a very complicated problem. Please move on to the next question. Here comes the next question. Find the momentum of an electron and the de Broglie wavelength associated with it. Of course, here also it is electron only. Its kinetic energy is given. Dear students, exactly similar to previous problem. First, you find out the lambda for 1.5 keV. K means kilo. Well, lambda is equal to, once again, h by root of 2 me. That is equal to 6.62 into 10 power minus 34 divided by square root of 2 into 9.1 into 10 power minus 31 into 1.5 into kilo. So I put 10 power 3 into electron volt. I put 1.6 into 10 power minus 19. Artha aagta idea? Okay, let us simplify this. See, that way compared to your PUC numerical problems, these problems are not that complicated. Okay, I think you also feel the same. Am I correct? Yeah, you are also feeling the same. Well, so the calculation goes like this. So when I am doing, please you also do simultaneously so that you will learn while watching the video itself. Well, so the answer is 3.169, right? Just 1 minute. I made a small mistake. 2 into see, it is no mistake. It is 1.5 into 10 power 3. 1.5 into 10 power 3 is nothing but 1500 electron volt only. See, in the previous video, we already have for 1500 this answer. So you have to get now also 3.145 only, or 3.15 into 10 to the power of minus 11 meter. So this is the wavelength. Got it? Now this is first part of the problem. Second part of the problem, momentum lambda is equal to h by p, therefore p is equal to h by lambda. So therefore p is equal to 6.625 into 10 power minus 34 divided by lambda is already there, 3.145 into 10 power minus 11. So simplify this. 6.625 to the power of minus 34 divided by 3.145 to the power of minus 11. So comes out to be 2.10 or 2.11 into 10 to the power of minus 23 SI unit. If you don't know the unit, you can write SI unit, or if you know the unit, better you write the unit. And anyway, it is momentum. Momentum is nothing but mass into velocity, therefore it is kg meter per second. So mass and velocity combination. So this is the answer for second question. Are you following? No? Do you find any difficulty? Please feel free and share your comments if I am not that much convincing you in numericals section. If I am too fast or if I am too slow or explanation is insufficient, please put your comments in the comments section. Okay, coming to the next question. This time it is neutron. Look at the particle. This time it is neutron. A fast moving neutron is found to have an associated de Broglie wavelength of 2 into 10 power minus 10 meter. So wavelength anna kottidare, particle yaudu anta helidare. They have given the nature of the particle, neutron. Find the kinetic energy of the neutron. Just to reverse of the previous problem with one change. What is the change? In the previous two problems it was electron, now it is neutron, but the numerical equation remains the same only. Well, lambda is equal to h divided by root of 2me. That implies lambda square is equal to h square by 2me, because I want E. Therefore kinetic energy, so take kinetic energy this side, then h square divided by 2m lambda square. Okay na? Now substitute, that is 6.625 into 10 power minus 34. Dear students, keep one thing in mind. For substitution there is 1 mark. If you don't do the substitution directly, you feed the value and write the answer, you may lose 1 mark. Better you do the substitution. Divided by 2 into 9.2, this is a mistake. I thought it is electron. It is not electron, it is neutron. So it is not 9 point. It is given, look at the question, it is 1.675 into 10 to the power of minus 27 into lambda is also given 2 into 10 power minus 10 whole square. Okay, this we have to simplify now. Well, I do it. 6.625 to the power of minus 34 square divided by 2 into 675 to the power of minus 27 into 4 to the power of minus 20, because 2 into 10 power minus 10 whole square. Yeah, it comes out to be 3.275 into 10 to the power of minus 21 joule. I told you, sorry, this is not lambda, sorry, please excuse me, I made a small mistake. This is energy. So I told you energy SI unit is joule. So if you want, you can stop here, you will get full marks. But better better to express energy in electron volt. How to express in electron volt? Divide this by 1.6 to the power of minus 19. Then you get answer as 0.021 electron volt. This is the final answer. So even if you express in joule also, you will get marks, but better to express in electron volt. Okay, with this move on to the next question. Again it is electron now. Please, whenever the problem is given, first find out what type of particle it is. Okay na? So position and momentum of electron with energy 0.5 k electron volt, k means kilo electron volt, are determined. I think this is on uncertainty principle, because he is talking about position and momentum. What is the minimum percentage uncertainty in the momentum? Yeah, it is about uncertainty only. If the uncertainty in the measurement of position is 0.5 angstrom. Dear students, you know what is Heisenberg uncertainty principle? According to Heisenberg, you cannot find both position and momentum of any particle with 100% accuracy. Always always there will be some error if you try to measure both of them simultaneously. If you measure simultaneously, this error comes. Means at a time you want to know the position and momentum, definitely there will be error. This is the essence of Heisenberg uncertainty principle. That clearly shows that in the subatomic domain, where we have particles like electron, proton, neutron, etc., no measurement is accurate, all the measurements are probabilistic. So this is the significance of uncertainty principle. In fact, you know one thing, when uncertainty principle was proposed by Heisenberg, he was just a 26-year-old young fellow, and the conference in which he made this announcement was attended by Einstein. Einstein was very much there in the front row, and Einstein said, "Oh, what a beautiful idea, what a marvelous concept this is. But I don't believe this concept." This is what Einstein said. Einstein never endorsed uncertainty principle, because according to Einstein, no measurements are approximate, no measurements are uncertain, nothing is uncertain in this universe. Everything is perfect. God has created this nature, God has created this world, God has created this universe in a systematic manner. Everything goes in a systematic and accurate manner. This was the Einstein's perception, Einstein's argument. But Niels Bohr, another eminent personality, did not agree with Einstein. He endorsed Heisenberg's uncertainty principle, and in fact Heisenberg is correct, Einstein is wrong. According to Heisenberg, no measurements are accurate, and it is true also. And why it is true? There are so many applications of uncertainty principle which we can see in quantum mechanics. Well, I will explain some of them in my video on quantum mechanics. So, Heisenberg uncertainty principle is one of the fundamental principle of quantum mechanics, you know. Like in classical mechanics, Newton's laws of motion are fundamental. Newton's first law, second law, third law, these are all very important for classical mechanics. So, without those laws, we cannot proceed at all. ಅದೇ ಥರ ಸಿಮಿಲರ್ಲಿ ಈವನ್ ಇನ್ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಆಲ್ಸೋ, ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಒಂದು ಫಂಡಮೆಂಟಲ್ ಲಾ ಬೇಕೇ ಬೇಕು. ಇಟ್ ಈಸ್ ವೆರಿ ಮಚ್ ರಿಕ್ವೈರ್ಡ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್. ಓಕೆ, ವಿತ್ ದಿಸ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ಟು ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್, now let us proceed with the mathematical form of uncertainty principle. You know, delta x into delta p greater than or equal to h by 4 pi, where delta x is uncertainty in the position, delta p is in the momentum. Let us call this as equation 1. Now we find out delta p first, that is greater than or equal to h by 4 pi delta x. Dear students, whenever numerical problem is given, write down the data present in the problem. Okay, so I just forgot to write delta x value. Delta x is 0.5 angstrom. Okay, well, delta p therefore greater than or equal to 6.625 into 10 power minus 34 divided by 4 pi into 0.5 into 10 power minus 10. Now let us simplify this first. 6.625 to the power of minus 34 divided by 4 into 3.14 into 0.5 to the power of minus 10. So this comes out to be 1.05. This comes out to be 1.05, sorry, into 10 to the power of minus 24. This is the error or uncertainty in the momentum measurement. Now let us calculate the actual measurement, actual momentum. Actual momentum P is equal to square root of 2me. Do you know this equation? I hope you know, because P square by 2m is equal to E. Therefore P must be this. So that is equal to root of 2 into mass of the electron 9.1 into 10 power minus 31 into energy is given as 0.5 kilo, that is 10 power 3 into electron volt into 10 power minus 19. I hope you are following. Well, simplify this. 2 into 9.1 to the power of minus 31 into 0.5 to the power of 3 into 1.6 to the power of minus 19. For this I have to take the square root. It comes out to 1.21. 1.21 into 10 to the power of minus 23. Nodi, idu original momentum. Idu error in the momentum. Now I have to find the percentage of error. Percentage is always given by this formula. Change in the value divided by original value. Please keep this in mind, dear students. Whatever may be the parameter, whether it is percentage change in temperature, velocity, momentum, energy, resistance, time, acceleration, whatever may be the nature of the physical quantity, percentage change is given by this formula. What formula? Change in the value by original value into 100. Okay, now substitute. Change in the value is 1.05 into 10 power minus 24 into 100 divided by original value. Just now I got it, 1.21 into 10 power minus 23. Well, I will do it for you. 1.05 to the power of minus 24 into 100 divided by 1.21 to the power of minus 23 comes out to be 8.67. So percentage change is 8.67%. Okay, that is all. Not P, it is percentage change. That's all about question number 4. Now we will move on to question number 5. Well, this is also about the uncertainty principle only. Please read the question. This is most probable question. This type of question you can expect in the examinations. I think you already saw these type of questions in your internal test also. Well, the question goes like this. A spectral line of wavelength 5461 angstrom has a width of 10 power minus 4 angstrom. Calculate the minimum time spent by the electron in the upper energy state. Nodi, whenever a question is given, first you read the question carefully, try to understand the data given in the question, and also try to find out what actually required for you. See, coming to this question, he is talking about wavelength, he is talking about the width of the wavelength, that is called bandwidth or the spectral width. And also he is asking you to find the time spent, that means delta t is required. So you know there is one more mathematical form of uncertainty principle, that is delta E delta t greater than or equal to h by 4 pi. Okay, I hope you know this equation. So this one we have to make use of. I call this as equation 1. Well, now coming to connection between wavelength and energy. So delta t is my requirement, question mark. See what happens, this is the ground state, this is the excited state. Normally atoms will be in the ground state. When you excite, no, they go to upper level. After spending a brief interval of time, they return to the ground state. During their downward journey, energy is emitted in the form of wavelength. That energy is given by E is equal to hc by lambda. So we know E is equal to hc by lambda implies lambda is equal to hc by E. You know this equation? Okay, so now I take this E is equal to hc by lambda, differentiate this equation, then it is delta E is equal to minus hc by lambda square into delta lambda. You know why? Because differentiation of 1 by lambda. Differentiation of 1 by lambda is what? I write it here in the bracket. Differentiation of 1 by lambda is equal to minus 1 by lambda square into d lambda. So this concept I have made use of. Okay, neglect negative sign and then go ahead. So we get delta E as hc delta lambda divided by lambda square. Call it as equation number 2. Now substitute equation 2 in equation 1. We get what we get? Yeah, delta E. In the place of delta E, I have to write hc delta lambda by lambda square into delta t, that is greater than or equal to h by 4 pi. Okay na? Now go ahead, cancel h on both the sides, retain only delta t here, send everything to the right side. So it becomes lambda square divided by 4 pi c delta lambda. So I have the equation with me. Delta lambda, this is one point where normally students do the mistake. Delta lambda, majority students they take it as 10 power minus 4. They forget angstrom. Dear students, put 10 power minus 10 also. So it is not 10 power minus 4, it is 10 power minus 14. Okay, now coming to the delta t calculation. So delta t is now greater than or equal to, lambda is given as 5461 into 10 power minus 10 whole square divided by 4 into 3.14 into c is 3 into 10 power 8 into delta lambda is 10 power minus 14. Okay, simplify. Let me do it for you. 5461 to the power of minus 10 whole square divided by 4 into 3.14 into 3 to the power of 8 into 1 into 10 to the power of minus 14. So this comes out to be 7.91 into 10 to the power of minus 9 second, or it is 7.91 nanosecond. Okay, that's all about this question. Please try to solve similar type of problem by choosing problems from previous question papers or from some of the textbooks. Okay, well, I stop this video here. I will come back to you on this particular topic with a few more problems in my next video. Please keep watching, like my videos, and also share and also subscribe. Thank you for your constant support and encouragement. In fact, I am really overwhelmed by your response. I am thankful to you. Your comments are so encouraging that it gives me extra energy to go ahead with the new concepts, new videos. Okay, thank you very much, dear students. I end this video here. Thank you.